All right, our second example in our Unit 4 probability examples is the probability of winning at least once on 2 tries of 3-card Monte. So the first thing that we have to ask ourselves is, what exactly is 3-card Monte? You read through it, but let's just go back over it again. So the idea behind 3-card Monte is that you have 3 cards. And one of them has a queen on it. Excuse my incredibly poor depiction of a queen. One of them has a queen on it. You're finding the lady, right? The other 2 do not. But all the cards get flipped over, so you can't actually see. So all the cards get flipped over and they get shuffled. And then you have to find the queen. So the question here is, what is the likelihood that you're going to win that game at least once on 2 tries? Okay, so the first thing worth noting is that this language, once on 2 tries, should sound like an inclusive or from last unit. So in other words, if you have to win at least once on 2 tries, it means you could win the first time, you could win the second time, or you could win both times. And all of those satisfy winning at least once. And so any of those are good. So we have to capture all of that. Okay? We have to capture all of those different ways of winning. So first, let's tackle the things that you can't do in order to make this problem work effectively. So we can't multiply here, right? Because it's the probability of winning at least once on 2 tries. Normally when we do multiplication, we're talking about successes over multiple events. So you're calculating the likelihood of success across multiple events. Right? So you can't simply just multiply the likelihood that you'll win the first time and win the second time. Because then you'd be calculating the probability that you'd win both times. But that's not what we need. We need either or. Right? We need first, second, or both. You also can't just add, right? So we can't just add the probability you win the first time to the probability you win the second time. Because if instead of 2 tries, this were 3 tries, so if instead of 2 tries, you had 3 tries, and you added up all the probabilities, well, the probability of winning, right, is 1/3. Because there's 1 card that's a winner and 3 cards in total. So your successful outcome is 1 over your possibility of 3. But on 3 tries, we would add 1/3 up 3 times. And that's no good because that would give us 100%. And although your likelihood for winning 3-card Monte on 3 tries might be pretty good, it's definitely not 100%, right? There's no 100% likelihood that you win 3-card Monte. That's just not how the game works. Right? So you can't add it either. So what can we do? Well, what's clever about this problem is what we really can do is we can calculate the probability of losing. And so we're losing is getting no queen at all. Right? Getting no queen at all. And then we subtract that from 1. Right? So it's 1 minus our loss probability. Why does that work? Well, remember that all probabilities sum to 1. Right? So if there's a 50% chance you win and there's a 50% chance you lose, then there's 100% chance you either win or lose, right? So for any given event or any given interrelated set of events, the probabilities of those will always sum to 1. And so if we subtract from 1 our probability of loss, we're going to get our probability of winning. If we subtract from 1 our probability of winning, we're going to get our probability of losing. And so the probability of losing is really the probability of getting no queen at all. So the question then is, how do we calculate this probability? How do we calculate the probability of getting no queen at all? Well, that, right, is getting no queen the first time, right? No queen on event 1, and getting no queen on event 2. And that should look really familiar because we just did and in the previous example. And is multiplication, right? So you're just saying, I can't get a queen the first time, and I can't get a queen the second time. And so we know how to do that, right? What's the probability in 3-card Monte that you don't get a queen? Well, there are 2 non-queen cards. And so the probability you don't get a queen is 2 out of 3. 3-card Monte always involves replacement. The cards always get put back and reshuffled. And so the probability that you don't get a queen in the second event is also 2/3. And so 2/3 times 2/3, you can do that. It's quite simple. That's 4/9. So the probability we lose 3-card Monte on 2 tries is 4/9. Well, we're looking for the win probability. So we have to take our loss and substitute it into this formula. So now we've got 1 minus 4/9. So I can change this 1 relative to the math that I know to 9/9. So then I get 9/9 minus 4/9. And that leaves me with 5/9. And 5/9 is a pretty good chance of winning 3-card Monte. In fact, it comes out to just above chance. Namely, it comes out to about, and again, this is an approximation, 0.556. So the percentage there, right, is 55.6%. So we have better than chance percentage of winning 3-card Monte. It's just barely better than chance, but we do have a little bit better than chance of winning a fair game of 3-card Monte if we get 2 tries. And fair is crucial here because, as the text notes, 3-card Monte is most often a con. Alright, and that's our last example for this tutorial.